Hey everyone, welcome back to my channel. Today I'm introducing a new subject, which is architecture system design. My main idea is just to provide you and teach you ways to develop common services that exist on architecture. For instance, today I will be talking about how to short or how to create a short URL server, meaning that sometimes you have long URLs and you want to make them shorter. Sometimes people think that, okay, that's useful when we want to tweet some messages or we need to reduce the size and we don't want to display all the details of the longer, let's say, URLs that are generated in some websites. But it's more than that. If you think, and I can give you a clue, when you create a short URL server, you create a middleman. You create a kind of I won't say a reverse proxy because you don't have balance and you are not choosing things behind, but it's a kind of a proxy that comes from outside. So when you generate a short address and people need to write this short address and they should go through a server that understands this short address and translates to a longer address, and it was you that developed this service. So you can do a lot of things regarding this address. You can monetize it, you can count, you can use it for marketing. There are a lot of things that you can do that I will explain in a moment. Remember that you have a middleman and you can do something about it. It's like as if when you have an API gateway, you have requests and you have your services behind the scenes, behind the reverse proxy, and sometimes you put an API gateway and you can do a lot of things on the API gateway. You can create strategies. You can say, okay, if someone is paying for my API, they have better access. You can authenticate, you can do authorization, you can log, you can do throttling, you can do a lot of things because you have always this middleman. And the main idea for you to create a server that can short URLs and people from outside, even application, and I say people can be applications, they use this short address. You can do a lot of them. For instance, one advantage, and just to give you kind of a spoiler and to check if you want to continue to see this video, is the case that if you short the URL, you can customize it. You can create nice names behind the scenes to provide to the outside, and then behind you have these strange URLs. Of course, probably you want to allow this customization of addresses and probably you want someone to pay for them, or if it's on your architecture, I think it's understandable if you have multiple services and you want to give them nice names behind these short addresses. Okay, you can always say, okay, but that's a service name, it's a different pattern on architecture, it's a different type of server. Yes, that's true, but you can use, for instance, this kind of URL server. I just want to tease you to check the rest. So the main idea, as I was saying, is just to provide you how you can build a server like this. I will build you one, and if you go to the timestamps, if you want to jump to it directly, you will see the code, how it works, how you can implement it in any language. I will use the Go language here. There are a lot of reasons for me to do that, but it's not, if you are not customized to this language, it's not so different from other languages, but it's a language that is quite popular on architecture, and that's why I'm using it. But after my explanation, and you will see that you can implement a server like this with just 3 or 4 methods, and I'm not joking, that's the truth. So the main idea is that if you look into my code, you can develop on your own code. The main idea is for you to understand how you can develop something like this. And if you understand how to develop, you can try in your own language. Otherwise, you can just clone my project. Maybe you can take my code and ask to ChatGPT or something to translate to Java, Python, or other language that you think it's more familiar to you. But let's start and see how can we create a short URL server. So first, what is a URL shortener? At the end of the day, it's something that you take this address, this big one, and you shorten it. And there are a lot of advantages around this. Let's see some of them. I put here in different slides a few advantages. I will not explain all of them, but you can pause and you can read it and understand better. I will just highlight the most important ones because I want to target how to develop it a server like this and what are the algorithms involved. So first is the user experience and marketing. I think it's easy to understand. It's smaller. You can even customize the names. And if you have a text and if you go back, it's better to write something like this rather than this one. I think we can agree on this, which is called the readability. The branding you can customize, as I was saying. You can give nice addresses to your customers or to your clients. It's easy to remember something like ABCD rather than all of this, of course. And even for testing, it's also possible to use this kind of things. Okay, because you can hide behind these addresses, the long addresses that belong to testing or something like that. You can call them test A, test B or something. I'm just, of course, creating these names now, but you understand the concept. And behind the scenes, you forward to the right servers. To the right servers, you can even catch the click and let's say create an event and count how many people are using the device or an application which is your test A and which ones are using or clicking the test B. You can do things like that. That's one other advantage, which lead us to this kind of thing like analytics and tracking. Of course, if you have the middleman, you can count how many times a URL it's clicked. You can create campaigns around it. And again, the name, it's readable, and at the same time, you can control and count and create nice dashboards with it. And yeah, a lot of things that you can do. You can even do some kind of a fraud detection. Because again, if you have the middleman, and that's the secret here, it's the main point of creating a server like this, you can check unusual clicks, the regions from where it's being clicked and things like that. You can do a lot of analysis of what's happening. Okay, the security, again, you have the middleman, you can blacklist, whitelist, you can check for spam, malware, obfuscation, because if you see, and if I return here, when you see an address like this one, you are revealing a lot of information about your API. You are saying, okay, to access this one, I have to provide this parameter with these values. This can change or not. That's a thing, but you are revealing a lot. And one of the things that you can do when you short something like this, you can change this and you say, I was thinking that when we create a server, a URL shortener, we hash this. Yes, that's one of the algorithms that you can use, but there are other algorithms that I will show you where you don't hash the string. Use a completely different approach, meaning that you can change this and still connect to a short address. It's quite strange, but that's the algorithm that I will show you. Okay, security, scalability, and reliability. It's caching friendly. It's lightweight. It's just a short one. And when you want to target the real one, you just redirect simply. Of course, it has advantages regarding the high availability, low latency, because just an hash or not, I will show you in a moment, to URL mapping. It's quite fast to translate one address. We have just one string. It's like an hash map somehow. It's not that, it doesn't mean that we will be using hash, but it's a hash map in the sense that you can have a shortened address like ABCD and you target a big URL. You say, okay, but the short address, they have an HTTP. But if you think for a while, it's not relevant. This address on the left, it's not relevant because it will always be the same for all of them, all of the short of the addresses that were shortened, because that's only this code that it's important. This one is just a server that will do the redirect, meaning that when you write this, you expect to redirect to this, but you only want to target this string. This one will always be the same. Okay, in data architecture integration, for instance, when someone clicks, you want to generate events, manage data testing or marketing campaigns. You want to generate an event and target, for instance, the marketing department and say, okay, is an event. And of course, when they click this link, you can get information, the IP address, some source. You can even guess what is the region. At least you can be a kind of a close approximation, things like that. So there are a lot of scenarios that you can apply when you have this middleman. Okay, so flexibility and control, dynamic redirects, something that will be done. You can even create expiry on the links. You can create these and you say, okay, this address is only valid for a while. Let's one week. And if you want to monetize, you can always say okay, if you pay more, I will give you more time on this, and then I'll start to recycle them. Okay, access control, you can block URLs. Imagine that you have a server that creates the long address, the real ones, but you don't put security there. You want to put the security in front of it, and you can control these shortened URLs. Remember that the shortened URLs is not as if you are creating a block and you'll be using it. You can use in your own solutions, architecture solutions, and make use of it. It doesn't have to be a public. Usually we are customized to see it as a public. We just want to shorten, put in our blogs or posts and similar, but you can use it in your own architecture. Remember that it's a middleman that you can control, and you are controlling the names. Then you can, of course, everything will be scoped by the algorithm that we'll be using to generate this address, a shortened address, but that we'll see in a moment. Which ones can you choose? Okay. Cost efficiency, and this is quite important. Sometimes people say, okay, short, why we all pay less? In the cloud space, it's not expensive, but the traffic is if you are going outside. And if you have long addresses all the time, it's more bytes passing by. And you say, okay, just bytes. Yeah, but if you multiply by millions of requests, it's just not bytes, it's megabytes. At some point, it will be gigabytes after a while. I once worked in a bank where we produced, and I'm not exaggerating, 200 million log records that were going through the network. So guess how much you have to pay for this traffic, just for logs. Of course, there were all other information like auditing, traces, metrics, and of course the business data going around. So when the scale is low, yeah, it doesn't seem important. But when you have a big scale, it's completely different. And I was once in a team, and there was a junior person, and usually when I'm on these teams, I try to coach them, and we are just creating a simple thing like a table, and we're defining the data types. And people usually, they don't care much about the data types they put there, at least from the size point of view. Of course, they care about data types, if it's a number, if it's a string, a varchar, and so on. But he was trying to understand if it was necessary to use 32 bits or 64 bits for a primary key. And I'll say, okay, first, how many rows do you expect here? And yeah, an integer can, even 32 bits can go, can allow millions and millions of records without any problem. And I asked him, okay, what do you think? I said, maybe I'll go with the long. We never know in the future. And I say, okay, imagine that you have, let's say, 100 million records on this table. And when for just one column, you can have multiple columns. And for one column, you move from 4 bytes to 8 bytes, meaning that you are increasing 4 bytes on just one of the columns, meaning that will be 4 bytes that are not necessary, multiplied by potentially 100 million records. So when you apply this, it will be 400 million bytes more without any need, just because I chose the wrong type. So sometimes this cost efficiency and the space that will be used, the low bandwidth, sometimes it seems that, okay, we are shorting this, I don't see the relevance. Yeah, always try to calculate how many do you expect and multiply by it. And then you have an idea how much traffic goes from one place to the other. And now I can add you one thing more, because usually, as if you are following my videos, you understand that I'm an architect and I like to provide architecture information. If this data is going around and we don't care about the size, imagine that this information, it's not about, this is shortened. It's if you are logging this or auditing this and you are recording this, there will be spaces on storage, there will be space on databases, there will be space on file logs, and these file logs probably will be imported to something like Elasticsearch that will have longer strings, meaning that the search can increase in time because the index and the strings are longer, so the search should go a few more bytes, and it will not be a few more bytes, because when we shorten, we have 5 of 6 characters that identify the short URL compared to 100, and if you put a token there, it can even reach 1000 or 2000, as I have seen some URLs. So that's always consider and do some math when you are doing or thinking about a solution for an application. Always ask, okay, how many clients will I have? What is the traffic that I expect? How many requests? How many response? how many call to the services, what this implies in terms of files, that database and things like that. And when you do this kind of calculation, first you are targeting to be an architect if you are not already one, a real system engineering or a software engineering, as I usually say, because you consider that and you understand that building software is not just developing. That's 50%. The other 50% is taking good decisions. And taking good decisions are the best decisions. It's not easy because you always are doing trade-offs. If you are not doing trade-offs, it means that you didn't do your homework. You are not doing the real work that you should be doing for your for designing your system. Okay, but I think that's enough for architecture at least at this time. So I choose Go as a language because Go is a popular language at the architecture level. And when we are designing this kind of services, if you don't understand the language, it's not a problem. I will teach you how to develop to URL Shortener. I will explain the code in a moment, and it will be it's just a small parts of the code. And this is not a very strange language, functional one, very crazy one. It's just they have files, they have structures, they have functions. They use a different notation, but they have ifs, whiles, fors, like any other language. So you should, maybe if you don't at first understand it right away, but you think they follow the same principles as other language. They have this language has some advantages from the concurrency point of view, performance. It's simple, it's quite fast, it's similar to C++. It's very easy to scale. They have great frameworks behind it. They don't call it frameworks, they call it libraries because Go doesn't like frameworks. And by the way, it's not a language to develop business services. For that, you have Spring Boot and others, and you can see the videos that I usually provide about Spring Boot on my channel. It's not that I prefer Spring Boot, but from my experience, if you have to start or choose a language for business, start with Spring Boot. Probably it's 90%, at least from the customers where I was in banks in Portugal and outside telecommunications. All of them, they were using Java Spring Boot most of the times to develop their own software. Okay, so that's why I choose Go. So don't go away. Keep going. I will teach you the algorithm in a moment. So first, let's see what features do we need. Just two. We have a long address and we want to short the address and to generate something like this. Of course, I will not generate this short hi. I will just generate a localhost because it will be my machine, but I think you understand the concept. And of course, after I have this short, I want to click on this short, not send it, click on it, and we'll target a specific server with this code, and the server will redirect you to the real URL. It's not the first one, it will be just an API saying, okay, take this long address and give me a short address. But the second one, it's not an API. It's calling directly a server using HTTP in a browser. And that's the example that I will show you after it's already implemented. I'll just show you the code. And by the way, the code, it's available on GitHub. And we'll just click on the link and you should be redirected to the real address, and I will redirect you to real address. So from the point of view of the architecture, since this is a series about architecture, so I try to design, let's say, a possible final solution for an architect point of view. Of course, I didn't implement all of this as an architect on my machine. I just implement the services, but the components that I created are very similar to this one. So in a real project, if you want to implement this at architecture level, you will, of course, you'll need a load balancer / reverse proxy, meaning that you want to call, and at the same time, probably an API gateway. So you send an API request, say, okay, take the long URL, just shorten it. Then there will be a distribution of the traffic for multiple instances here. I just put one component here, but it can be, it should be at least two if you are creating a real project for this. And where you can see the API gateway handlers. I put it here handlers, but you can call it APIs. In Go, we call them handlers. If you are a customizer with Spring Boot or similar language, it's where the APIs exist. It's the controller. Okay, it's almost the same thing. I will try to, for those that don't understand Go, I will try to map, but think as a controller. So it receives a control. The control then goes to the core logic or service, which is a service in Spring Boot or other frameworks, or the business layer, or whatever you call it. And you can have a specific server for this. So in a real architecture, you need a load balancer, API gateway. Sometimes they are merged. I don't know if it's a good idea. Probably you want a kind of a firewall here and other types of things. But in a simple solution, I didn't want to go full scale here, but at least minimal scale for the implementation. So I have load balance, API gateway. Now you have another machine. In our case, it's just a method. It's just a file. but which is this box here. It's our application. But if you think for an architecture, this will be a machine with multiple instances or multiple machines, depending if you are using Kubernetes, if you are using virtual machines, containers, or real application, real servers. Here will be where the service really exists, that will short the URL. And then, of course, we have to store this in a database, because on the second, after you generate the short URL, you want to click it, and you go through the load balancer, you go to the handler, and handler should go to the database and check if it exists, and if it exists, will redirect you to the final destination. So this service to short, of course, it needs a database. In my case, I use an in-memory database, which is just 2 hash maps. It's just a map that maps, when you provide a long address, I will generate a short one. So there is an hash map with a key, which is the short one, and the long one with the value, and another one which is the reverse of this. I have the long one, and I map to the short one. So I can, when I receive here for a short, I'll go to the short one, and I can check if it exists or not. For a long, imagine that someone provides a long address twice here, and I can go to the second table or the second hash map and say, okay, this is the long address. Did I already generate the short address? Yes. Okay, it's just return that one. It's not necessary to generate again, and that I implemented. And of course, in a real application, you want to put some cache, because after you generate, there is no reason for you to go all the time to database, because it's already shortened. It will always be the same. So if this database it's in a physical storage, you want to put the cache in the memory. It will be faster. So you receive the request, and you do all the logic. And probably you can, if you have good memory on your server, you can put a lot of the short addresses here on the cache. So this handler can just ask the core logic, hey, they provide me this short address, so you go to the cache, it exists, great, I'll redirect. Otherwise, I will generate, store in a database, put on the cache, and return it. So the next requests will go here. Remember, it's just 2 features that we have, but this is very similar to an architecture. You can think about this box at different machines. In my case, I implemented this handler, I implemented this core logic, I implemented this, let's say, database in memory. I didn't put a cache because it's database already in memory. There is no reason to put a cache, but it's easy to add a cache to these kind of things. It's just add a framework with a cache and just put the keys there and expire them if they expire here, if it's necessary or not. But since it's in memory, I didn't provide that. But if you want a real application, this is, I think, a really good start design. Maybe it's 1 or 2 components can be different here, depending on your architecture, but it should be very different from what you see here. So this big box can be your, let's say, cloud, where resource group in Azure or other terms in other, like AWS or others. And I think it's security group in AWS, if my mind doesn't trick me. And these are servers. But in my case, this URL Shortener service is an application with all of these as files. But I tried to do a mapping, and it's quite nice, and it fit. It was great. So this is a possible architecture. So let's see the algorithms that you can use. I put it here, 2 algorithms. One, it's just using a counter. And you say, a counter? Yes. So imagine that you have a counter that starts on 0. And every time you receive a long address, you decide, okay, what is the current counter? It's 1. So I will create something from this 1. Okay. And then 2, and then 3, and then 4, and so on, and so on, and so on, until you reach a big number. If you have 1 million, okay, we'll do something with this 1 million, and you just put it on address. And since you are storing the long address, it's not necessary to hash it. You just use the number to generate. And when you receive the short value, you go to database, as I said previously, and you understand what is the long address, and you just redirect. And it works. The main advantage of this approach is that you are not linked to the long address, which means that you can even change the long address without changing the short, because it was generated by a number. But there is, of course, a problem here that I will show you how you can resolve it. But for now, the guarantee is always uniqueness. If you have 1 server, but if you have 2 servers and are you using a counter, then you have a problem, because each server will have its own counter. So if you have two requests for the same, even for two different long address, they will generate the same short address, which will be a problem. You can always say, okay, maybe I can put this counter on a database or in a Redis cache outside and make sure that it's locked, so each server go there. Yes, you can do that, and if you are thinking like that, you are always being an architect somehow, but you have to go outside. Every time there is, if you have millions of requests, you have to do a jump between servers. It means that you will increase the latency. It will increase the time of the response, because you have to go to another server, do some stuff, get the value, increment the value, and then you do your calculation. So it's not a good solution, but this is a solution that I created, but I will show you how you can completely remove nicely and in a standard way and the correct way this problem with distributed systems. Another thing that you can use, that probably it's more intuitive one, that people think out of the box when they think about how to short URLs, is using hashing, meaning that you take the long address and you just hash it. Of course, you will not provide the full hash because it will just be crazy. That will not be readable. It will violate a lot of the advantages about being short, So if you want to short, maybe you take the first, let's say, 5 chars or 6 chars. And that's a good approach. The problem is that there can be collisions, which means that you can generate something for a long address, and when you have 6 and you store it, and then you have a different address, and when you hash, by coincidence, the first 6 chars are the same to one that already exists, but the long address, it's different. So in this case, it's quite strange, because you have to check if it already exists, but you cannot take the decision that exists because the long address, it's the same. It can be different. So you have an additional comparison here. So one of the ways to work around this is just try to, rather than use 6 chars, use 7. And probably it should work. It doesn't mean that now on you'll use 7. You'll return again to 6 for another. And if there's a collision, you increase to 7. If there's still a collision, you go to 8. With 8 or 9 shines, I have my doubts that there will be collisions. But you have this additional complexity, additional things that you have to do, like the first one when you try to put the counter outside of your application. One way to work around simple counter, which is the one that we'll be using, is using something called distributed ID generators using Snowflake. And let's see how can we do this. First, if you saw here, I didn't talk about the counter will use base 62 encoding, meaning that we'll be counting, but we're not using decimal. Otherwise, the short address will be just numbers, and it's not nice to see them, and it will increase. When you have 1 million address, people understand that there is already 1 million there, so you are revealing too much, and you have 7 chars. So we have to, let's say, use a different, I won't say decimal system, but a different numeric system. You're not binary, you have zeros and ones, okay? You have octal, where you have 8. When you have decimal, you have 10. And when you have hexadecimal, you can have 16 values with just one char or one position. And then you have 16 multiplied by 16 to have 2. In our case, you'll be using base 62, meaning that imagine hexadecimal as 16, but you'll be using 62. So for each char, each position as a first char, we can get 62 positions. And then with 2 chars, you can get 62 multiplied by 62. Let's see how can we do this. So the main idea is just to create our decimal system, which, by the way, will create this string here. And if you count here, you will have 62 chars. It's 10 for the decimals, 26, 26, and you have all of this. It means that the number 1 is representing by this 0, or the 0 is 0, 1 and 1, 2. But for instance, when you reach the 8, it will be 10, 11, like the hexadecimal, until you reach F, and then 17, 18, 19, 20, until you reach 62. So you can, with just one char, you can reach the 62 positions. And if you start to combine 1 with 0, 1, 1, 1, 2, 1, 3, 1, K, 1, L, you have 62 multiplied by 62. So now you understand how you can get a lot of different short addresses, millions and millions with just a few chars on the short. That is really great. But let's see how can we generate them. why we are using base 62, it's what I was talking about. So you can reach 56.8 billion unique URLs with this base 62. And if you do some accounts, imagine that you want to use 5 shards for your shorts. It's 62 powered 5. 62 multiplied by 62 multiplied by 62 multiplied by 62 multiplied by 62. And if you do the math, you can see that it's a big number, and a big number of URLs with just 5 shards. If you go to 6, you have more than that. Okay, and it's human readable because it's just shards and numbers, and they are safe for the addresses. And that's why you see a lot of shortened service where you see A, B, and things like that, usually letters and numbers. Probably behind the scenes, they are using this algorithm. Okay, so the first thing in our code that we'll do, it will create a kind of an array or a string with all of this. And every time we need something like, let's say, 13, we try to guess what is the 13th position. But let's see how this works. Let's try to get the number 1, 2, 3, 4, 5 and convert it to this base 62. Imagine that's our counter is now reaching. Remember that we are using a counter, and our counter now has this name. What will be the short address generated? So the algorithm, it's the same that we use to convert a decimal to binary. You just divide by 2, and you take the remainder, right? And you will divide until you have nothing more to divide. And you always take the remainder, you concatenate all of them, and you have the final result. Of course, it's not binary, it's base 62, so you have to divide by 62. So if you take this number and divide by 62, you will receive this number here with a remainder of set. So you can see here it will be our first number for our address. Now, since we still have something to divide, we take this number 199, again we divide with the 62, and we get 13. That's something that we are not used to see as a reminder in the number like this, but in this base 62 it's common. Well, you can see this, for instance, in hexadecimal, for instance. But the 13, if you go, you will see that it's the D, because it's the 13th position here. Remember that any reminder dividing by 62 will always fit in one of these shards, because you have 62 shards here, right? So now it remainder 3, and we put the D here on the left, and now we still have this 3. We divide, of course, it will get 0, but a remainder of 3. So our number 1, 2, 3, 4, 5 is converted to 3D7, and this 3D7 will be our shortcode. And this is the only thing that you need to implement your short service. If you understand everything that I said until now, you just need a service, an API that receives a long address, let's say in JSON, with an attribute. You have an internal counter, let's say a singleton, in a singleton, and you just increment it, and you just apply this algorithm, and you return it, and that's it. It is as simple as that. Sometimes people say, okay, it's a shortened service, maybe there are some hashes involved, a lot of things. No, it's really easy. It's the concept behind that. It's quite elegant to understand. And that's it. So when I said that I implemented in Go, and you can implement in a different language, I was not joking. It is as simple as this. Okay, you can implement it right away. So why it works? First, it's a mathematical principle, meaning that you have bijection. What is bijection? It means that you can go to the counter to these characters here, but you can also go the other way around. If you take this and multiply by 62, which is the inverse of what you have done, then you will reach this value. That's what this bijection is about in math. Okay, and the rest, of course, it's what I said previously. But of course, you have the problem of distributed systems, because the counter is in only one place, and in terms of scalability in a single instance, it's always unique. This always generates unique addresses, because again, you are just converting a number that's incrementing in a singleton, and this number will always be different. Why? Because you have this mathematical principle about the bijection. Okay, so let's see what if you have multiple servers, multiple instances, and you want to use the counter, but you don't want to centralize this counter in an external system. So the trick is just create different counters, but counters that never intersects with each other. And this is used if you go and read documentation about the data architecture and things like that, or sharding on database servers. You will start to see something called Snowflake-Style IDs. And the idea is just to take a 64-bit like a long. You just ignore the one that is responsible for the sign and similar things. So you take the 63 bits on the right side of your long, and you take the first 41 bits as the millisecond since epoch, and this is standard in operating systems. All the language support this. You can get at the specific time how many milliseconds have passed since the epoch. That's and it's something, and always fits in 41 bytes. Now, since you have multiple nodes, multiple instances, multiple servers, you should assign a number to them. That's and there are several ways to do that in architecture. Sometimes it's already there, depending on the system that are creating the replicas. If you are controlling them, you can just pass an environment variable, say you are number 1, you are number 2, and number 3. If you are using Kubernetes, you have different ways to do it, but you always have a way to get a number for it. And you keep 10 bits on this long for this, and 10 bits to 1110. I hope I'm not wrong here, but it should be something like 1044 and 24 servers. So it's a lot. It means that you can have 1024 replicas, servers for your short variable result. And then you have a 12-bit sequence to your counter. And you say, okay, but 12-bit, if I do the math, it's just 4,000. But there is no problem when you reach the limit here. Because imagine that you reach the limit on your counter. You can return to 0 because the time that you reach the limit, this time has passed. So the combination of time and the number of the server and this, it's always unique. And you can see here an example. So even for a simple thing, you can see something like this. And the encoding will be something like this. That's why even if you create a new URL service, you don't have the risk to see 1, 2, 3. It will be quite strange for when you generate it. It was like someone, okay, I was the first to generate. If you're using this technique, it will be, it looks like if you have already created a lot of them. From the marketing point of view, it can be a nice thing, okay? And the short address, okay, it will use this. Remember, this is not the counter. The counter, it's here. Here it's a node, here it's a timestamp. But you take this whole value, okay, and you apply the algorithm that we saw before. Advantages, there are no collisions between cross-distributed servers. This combination here, it avoids completely any collision with this number. It's time sortable. When you look into this number and you convert to binary and extract these 4 bits, you can have a story about how the counter increase. There is no central coordination. Each server can use this, so you don't need that additional op or call to an external service. So you spare a lot of time on the latency, and it's easily coding as short variables because it's still a long, meaning that you can divide and use this algorithm to generate it. Okay. And that's it. So if you want a professional thing, I left here a few topics. Of course, I didn't implement any of them, but if you want to think about it, okay, custom shortcodes, if you want to sell them, someone can buy my site or something. Analytics, you can count them. It should be easy for you to, since you have the server that receives the request for the direct, you can count things for specific addresses. Of course, you can add expiration, user authentication for some of them. You can have some of them say, okay, I want to generate this one, but I want to create a username and password to protect it because I want to use for protected things on my service. Rate limiting, you can have some of them that are public, other ones are private, others are premium. It depends on how are doing business with this server. And the other ones, you can see database persistent, caching layer, robust handling, logging. Of course, I didn't implement all of this. I just wanted to target and show you how you can implement quite easily a first version that you can improve by adding these features. There are other features for sure that you can add. So let's see now this working. First, thank you. If you reach here, by now, I think you should be able to create a server on your own. It's quite easy. It just, if you go back and see the slides, they are self-explanatory. But if you want to go how to implement in Go, meaning you can map to your language quite easily, just wait a few seconds while I switch to my application. Okay, this is my project in Go. Don't get scared by this. If you already use something like Spring Boot or a language with 3 layers like a controller, service and data layer. I will explain to you how is this developed using that way. So it should be easy for you to understand. By the way, again, this code is on GitHub. You can clone it and exploit it later. I put a lot of comments here that you can follow. So this is the main, it's concept of main, because Go follows somehow some standards from C and C++, but it's a different language. It has a garbage collector, things like that. You can check from that. So first, let's see the structure here. So the application starts here. Then I have some configurations where you can see constants like the port of the server, the default base URL. This default base URL is quite important because it will say what is our short service. Mean when I generate the short code, I will concatenate here on the right side. Meaning when someone clicks on this link, okay, with the short, I will receive it, I will decode it, I will extract the code and try to find this address on my database and then redirect the user. Okay, and of course I need the base 62 shards because I need the positions here to generate the value. Now we have the handler. The handler, it's the API or the controller, if you want. Okay, you have this, by the way, Go doesn't use classes, but you can somehow, it's very, I won't say it's complicated, but it's not usually for people that never saw Go. But if you create something like, let's say this handler, a type, let's call this what you think it's as a class with attributes. And if you put these on the left part, you can see here that you have a function, you have a name. These are the parameters, and option you can have here a return type. When you put like this on the left, it's called receivers. But let's say that you are linking, it's like as if the Go will inject to you an instance of this handler here. It's like if this method belongs to this type. I think it's the easiest way to explain this. It's more than that, but if you want to understand and you are customized with C#, Java, or language object-oriented, it's when you put this on the left, it's like as if this function, it's inside this, and it has access to these attributes by using this variable here. By the way, these stars here, it means that there are pointers. So Go supports pointers. It's not relevant, just look at them. It's a way, think of them very similar like the reference that you have in Java or other languages. It's not the same thing. If you came from C or C++, you know what I'm saying, but you can think about that. So here you have this method that will be our REST controller. You don't see annotations, nothing here. You just see here a response writer and the request, like similar to other languages. And now I'm just testing if when this method is being called, the request that I'm receiving, if it's a post, if it's not, I will throw an error. And now I take the JSON and I expect a JSON like this one. You can see here an example. So you provide this JSON on the body, okay, and I should answer with something like this. So here, this new decoder JSON on the body of the request, you can see here, I'm just targeting this, okay. And there are this rec, which is a structure that exists. Let me see. It's another place I will show you in a moment. Probably it's here. No, not here. Okay, I will show you in a moment, but it's just to understand this and the value. It's the usual stuff. When you, let's say, what I'm doing is just deserialize to this variable I'm just deserializing, okay, the value. Okay, now I check if the address that I've been provided it's it's a valid URL. Of course, for a proof of concept, it's not necessary, but as I promised, I will create a solution very close to an architecture one that follows the good principles. That's why I have put all of them there. Of course, this one probably it's not necessary. This one is not necessary for demonstration purpose. Only this one will be necessary. The code will be smaller, but I want to show you how to develop a professional thing. And now, since now it's valid, so I will take the long URL from the request, meaning this part here, okay, and call the method shorten URL. And then, of course, I will respond here on the models. By the way, they are here, the models. So this is the one that represents the body of the JSON for the request. You can see shorten request and the response, oops, not this. And the shortened response is just a short URL. This one, it's long. And you can see the Go use a different approach on the serialization. Since it doesn't have annotations, sometimes you will see these kind of things after the data type, saying that when you serialize to JSON, it should be like this, and of course the serialization. So again, the handler, it's the controller, and of course we have this one that shortens, and we have of course the redirect, meaning that when you click a specific shortened address, and imagine that it was the right part of the address, it's this one because that's the code that is interesting for us. Again, I'm validating here the get. I'm get from the address this part because that's what matters to me. Okay, then I'll check if it's empty. If it's empty, okay, there's nothing to do. If it's not empty, okay, I'll go to the database using the shortcode and I get the long address. And of course, I will redirect here to the long address. Okay, HTTP. It is as simple as this. Most of the code here, it's validations. You can ignore it. If you are just to implement it, just understand what is the objective. This one is just to extract from here this code, go to the database or to the cache, get the long address that you store it before here, okay, when you short this URL, and I will show you in a moment this method, okay, and you just redirect to it, the long address. That's it. Now, this is the handler. The service, it's your business, and in the business, of course, this is where the methods exist. The types are just records or classes or data that, like you see in Kotlin, for instance, it's where you put your properties. So this is just receives the long address and will shorten. What should it do? It's just quite simple. I just go to database and check if it exists. If it exists, nothing to do, just return it. If it doesn't exist yet, so generate the shortcode. And of course, save it on the database and return it. So how to generate the shortcode? It's quite easy. Just increment the counter. Remember that we are using a counter. I didn't put here the Snowflake IDs. It's just a counter, but it should be easy for you. If you want to try the Snowflake, just put it here. You have to get the milliseconds of the system. You have an API for that, and put it on 41 bits. Then just give a number to your instance, for instance 1, and of course you still need this counter. You put everything on the long, and then you pass here the parameter. Here I'm passing the counter, but you can pass the Snowflake ID here if you want. So this is the guy that generates the code here, and you just return it. Return to the handler. And of course, you can see here on the storage when we save, again, it's here on the storage. So it is a 3-layer. The handler, it's the controller, the server, it's the business, and the storage, it's the memory. In our case, it's memory. It could be a real database. And the storage, you can see that you have 3 methods. This is an interface. It's very similar to interface in other languages. Just define the methods that you expect to exist here. And now you can see here the save. There are a lot of comments here. This is just locking, because it's a professional application. Of course, for the demonstration, it's not necessary. But here I'm just locking the access to these maps where which are hash maps, where I put here the short code, and this is the long address, and here's the long address and the short code for the reasons that we saw before when we need them. And here you have this instruction. I think iOS, the swing, I think it's swing, the language. Defer means that I put a lock here, and it should unlock at the end of the method. You are deferring for later the execution of this. This statement will be deferred until the end of the method. I think it makes the code readable. That's one of the objectives of Go. So this is just to save to the database. It's quite simple. First, it checks if it exists. If it exists, just return it. Say, okay, it already exists. I don't understand why are you saving it. If it doesn't exist, I'm just putting on the long to short. So I receive a long address, and I create the long, I'm putting, okay, I'm checking if the long address already exists. And here I'm storing on database. You can see this as a kind of 2 tables or 1 table to index, depends how you want to implement. But at the end of the day, it's for the short code, it's an hash map, targets long and the long, the short, this is our database, is just 2 hash maps in memory. Of course, if you are using a real database, in those cases, you will have 1 or 2 tables where you save it here. Okay, of course, you have to adapt the rest of the code. So let's see now the main. The main, it's kind of using the pattern dependency injection. So you create the storage, here, we call this method new, and we'll create an instance. Then we inject the storage here on the service. It's like when you do it in a common framework like Spring Boot and things like that, but it's done automatically on Spring Boot because the framework supports here. We do it manual, but the pattern is the same. And of course, we take this service and we'll inject it on the handler, which is our controller. Okay, and don't forget the base URL because it will be used to concatenate on the right side the address. So this is the initialization. I think it's easy to read this if you look into these methods and you want to explore later. Optionally, I put this some environment variables, what should be the base address and the port and things like that. Now here are the APIs that I'm listening to. You can put it here, you can move to another file. I just put it here because it's just 2 rows. There is nothing more, but usually you can put here on the handlers. Sometimes we create a folder called server and you put the roots there, and the roots then will target the handler. So usually you have a kind of a server, and the server targets it's a kind of a manager that targets the handlers, and the handlers are connected again to the service, like we did it here, and the service connect to the storage, a 3-layer architecture. And then there's some logging to be nice to see the output of this, and then you start the server. You only did this one. I put this one because there are options that you can put. It's quite advanced. You create a server here, and this is listen server. It's very similar if you already work with Node.js. It's very similar to it. Okay, so let's execute this. I already compiled it. So you can see here, this is starting on this port. This is our server, and because of this log here, you can see we have a post and you have a get. So the post shorten code, meaning that we want to provide an address, and get we want to redirect. Okay, but let's see this working. I create here a few tests. Imagine that you want to do our post shorten. Don't forget that's our API, and we send this JSON. If you remember, I have talked about this. And let's execute this, and you can see that generated with the number 1 because we are using a counter. And if I click again, since we in our method we are validating if the long address already exists or not, because of those hash maps, it still generate. It will not generate. It will just return what already exists. And you can see that I'm clicking a lot of times. It will always be the same. If I change these and let's put some, let's say Google, it's a different one. And I put a request, and you can see 2 here. And again, if I click several times, still 2. Now, if I do here and put again Apple, no, it will not generate. It just return one that already exists. Our database, it's handling 2 at least address. And now I could call a get, but let's see this in a browser. So we want to use the 1 and the 2 in our browser. Remember that that's the main point. We don't call an API. The API is just someone clicks on the address, it will target our server, and our server, it will receive a get, and we'll extract this number 1, and we'll look into the database if there is a long address, and if it exists, it will redirect. Okay, so let's see here. I will put it here. Our address 1. Remember that our server is running, and it just this is it's putting Rededit because I ran before this. I don't know why Vivaldi still. I will just put here file. I don't understand this browser. I already clean. I put private and still went to some local cache. I'll put a private window here. I think it's better. And I will just again write this. And you can see the Apple. There is some cache on the other, and Vivaldi really push to the cache. It doesn't check if it's true or not. I think so. That's the 1. And the other one, we can put the 2 here. And you can see the Google here. Okay, again, 1, Apple, 2, the Google. And you can see that our server, it's working. This one, it's appearing like this because, yeah, the Vivaldi, I usually try to use this browser for this, but for some reason, it's cache. It really cache the URL because I did some tests, as you may guess, when I developed this application. I want for them to work, and I tried Reddit, and now I'm using different, but when I put it here, 1, it still goes for this. Of course, you can improve the solution and put some headers to make sure that you remove the cache from the browsers and things like that. But yeah, this is just a simple one. So this is what I want to show you about this, how to develop a server like this one. I took a lot of time, but yeah, you have timestamps. You can always go back and forth on my videos, but I really like to explain in detail why I take these decisions, give good explanations about it. Of course, I can create a video like this in 5 or 10 minutes, but it's just showing. I think you don't learn nothing by showing. I want to understand why the decisions are taken, why some methods are better than ones, why what are the advantages, what are the disadvantages, and so on. So I hope you liked my video. I hope you learned from it. Try to develop your own, maybe in Go or any other language. Share my channel, subscribe to it. It's always a motivation for me, and I hope you like it, and I hope to see you in my next video. So thank you.